And then we'll review a little bit tomorrow. Quiz on Friday, which goes on second 9 weeks. Later. Connect. Good. Okay. Division algorithm. That's long division. Talked about it yesterday. Finish it up. Finish it up today. Then we'll talk about synthetic division, and then we'll hit two of my favorite theorems, the remainder of the factor theorems. Okay, so very, very useful theorems. We want to hit those, and then clean everything up. Quiz on Friday. Did we get to this one? It didn't look like it. No. All right, good. Write this one down. We're going to do long division here. And Lizzie, we struggled without you yesterday at Spirit Club.
Oh, I know. I was
did.
really sad.
I know, we were sad. But we did come up with Spirit Week. Monday, monochrome or neon day. We kind of did a little combo stuff here. So, you can go all gray. You can go the drought fit. Okay. You can go all white. I don't know what that's called.
White out.
White out. You can go white out. You can go neon if you can't pull off the monochrome. Okay, you can go neon. So you got options. I think they kind of fit together. Tuesday, dress like a teacher day or twin day. You get somebody. You can go triplets. I don't know. There's no limits. We're not going to limit you. Okay, so you can do that. And then Wednesday, it's way back Wednesday, which is way back for me. Decades Day. Pick your favorite decade. All right. You can go 80s, 60s, 70s. What would be, I don't know what would be 90s. I don't know what qualifies that. And then Lake Spirit Day on Thursday. So, a lot going on. All right, one thing here. I want you to be careful. What's it missing? It's missing x squared. You got to put a 0 in that spot. Okay, if you don't, then everything will get gummed up. So, and the same would be for the divisor. The divisor's not missing anything, so we just go like normal. So it's x squared plus x minus 3 divided into 2x to the 4th plus 3x cubed plus 0x squared minus 5x plus 4. All right, process from yesterday. Kind of for me mentally, I say what times x squared gives me 2x to the 4th. We're only worried about the first term at each time. So Justin, what times x squared gives me 2x to the 4th? 2x squared. Now I like to put it right over the x squared, kind of keep my degrees lined up. It's not a deal breaker. You don't have to. It's just nice. So then I multiply here. I get 2x to the 4th plus 2x squared minus 6x squared. So do you see why we put in that 0x squared so it lined up? And we're not like trying to combine the 5x with that. Subtract that whole thing. So you're going to subtract that whole thing. When you subtract it, make sure you distribute the negative. All right, Dakota, what does that give me? What do you think?
X cubed plus 6x squared minus 5x.
Good. It'll give me that should be a cube there. Sorry. That's what you guys are looking at me funny for. X cubed plus 6x squared, and then we bring down the minus 5x. All right, Tony, what do I multiply by now? X. X times x squared gives me x cubed. When you write it down, make sure you put plus x. X times x squared, x cubed, plus x squared, minus 3x. Subtract everything. All right, as you're subtracting, Andrew, let me know what you get.
5x squared plus 2x plus 4.
Plus 2x?
Yes. Minus 2x.
Minus 2x. All right, good. That's what I was thinking. Plus 4. All right, now, all right. Brooke, what do we want to multiply by? 5. Okay. You keep going until the degree of the divisor is what your answer you get as you keep moving down, or excuse me, the degree of the remainder is less than the degree of the divisor, which is what we're here. So that as long as they're the same, you can multiply by 5, you're good. So plus 5, and it gives me 5x squared plus 5x minus 15. Now, this one does not equal 0. The last two cases, I think they all came out to be 0. All nice. What do I get when, or let's take a look at what we get when we subtract 5x squared minus 5x squared. We got to make sure that's always 0. Then I get negative 7x, and then make sure that's going to be plus 19. All right, what do we do with that? That's your remainder, but go back to, hold on here, 5 into 22. You'd say 4 times 5 is 20. You would say that's 2, and so our answer would be 4 2/5. So we're gonna do like that. So this is gonna go over top of my divisor. So my answer will be 2x squared plus x plus 5. I'm always going to put a plus, and then whatever my remainder was, what was it, negative 7x plus 19? Negative 7x plus 19 over x squared plus x minus 3. All right, it may not make 100% sense to you right now, but I want you to understand something. What would I get if I multiplied this times that whole thing?
2x to the 4th plus 3x cubed.
Minus 5x plus 4. Yeah, you get that top piece. You get that numerator. Yep. So it wouldn't be pretty because you got this here, but that's what happens. Okay, nice something to do. You're a little bored Friday night. Multiply those two together. Show that they come out. All right. So this is a case where it's not 0. Okay, it's not 0. Synthetic division. Used it last year. Okay, synthetic division is nice. Okay, it's probably slightly easier, but it doesn't work for all cases. Here's where it works. It works when you just have an x minus a constant or x plus a constant. You can't even use it with like 2x minus 3. Okay, it won't work. Just x plus or minus. So use when dividing by x plus or minus a, where a is a constant. Okay? If you are dividing, and I'll show you what this means in a second, by x minus 3, you will put a positive 3 in the box, which I'll show you in a second. And if you're dividing by x plus 3, you're going to put a negative 3 in the box. Okay, you always want to think about it as x minus the constant. So this would be x minus the negative. When you have this, so you have x minus 3, we put 3 to the side, and then you put your coefficients down. 2, 4, 1, negative 15. Okay, 2, 4, 1, negative 15. All right, remember what you do first? It's been a while.
You carry the 2 down.
You bring the 2 down, and now here's what I do, is I always put a 0 here to hold that place, but the same thing, you bring that 2 plus 0 gives you the 2. To get the next number over here, you take the number on the bottom and multiply by the number in the box. 2 times 3, 6. And then you always add down to get the next one. So 4 plus 6 is 10. And then 10 times 3 is 30. 1 plus 30 is 31. 31 times 3, 93. And what do I end up with? I end up with 78. Now, I automatically drew in that vertical bar there to separate the last number. The last number is your remainder. Okay. This other part is your answer. We have to put in the x's. It's always going to be 1 degree less. Sometimes it's called a depressed polynomial. Doesn't have anxiety issues. Okay? It's because it's always 1 degree less. All right, so my answer of that division problem is 2x squared plus 10x plus 31 plus 78 over, what was it, x minus 3? X, because I got a remainder. Plus. Okay? So that's what you get when you divide by x minus 3. You can go through and do long division. Okay? But I think this is easier. It's quicker and it's easier. All right, a second one. 3x cubed minus 9x squared minus 4x plus 12 divided by x minus 3. All right, since it's x minus 3, we put a positive 3 in the box. I got 3, negative 9, negative 4, 12. You get a 0 there. All right, add and then multiply. Add and then multiply, see what you come up with. All right, so I got, I get 3, 3 times 3 is 9. All right, I get negative 9 plus 9, which is a 0. We'll keep going. Don't stop. 0 times 3 is 0. Negative 4. Negative 4 times 3 is negative 12. Okay, that's my remainder. That's kind of good. It means it goes into it evenly. Okay, there's no remainder left over. Just like in when you're doing, whoops, yeah. When you're doing long division, if you get a remainder of 0, it goes into it evenly. But what's your answer? Okay, that's our answer. It's just going to be 3x squared. I don't need to put plus 0x. I can put minus 4. Okay, if you want to. So when I divide this, that equals 3x squared minus 4. And you don't need to have to go through all this, but I want to make sure I explain it. That also leads to the fact that what is 3x squared minus 4 times x minus 3? If I use our division rules, what does that have to equal? It's got to equal, if I take that times that, it has to equal that numerator. Okay, so it would be 3x cubed minus 9x squared minus 4x plus 12. All right, so we're good there. We'll take a look at one more using synthetic division. And I want to use that because it has an x plus 1. All right, now what's this one missing? It's missing a cube. So what do you got to put there? 0. You got to hold that place with a 0. So be careful. You might want to wait a half a second before you write it all out. So in the box, negative 1. And then I do my coefficients, 3. And it can only, like I said earlier, it can only be like an x plus 1 or x plus 2. It cannot be like even have a 2x. So it's limited when it's useful, but it will come in handy. 3, negative 6. All right, I'm missing x. Whoops, I'm missing x cubed. So that will be a 0. So 3, 0, x squared is negative 6. X is 3, and then I got minus 7. So I start with a 0. I add vertically. I get a 3. 3 times negative 1 is negative 3. Add, get negative 3. Negative 3 times negative 1 is 3. Negative 6 plus 3 is negative 3. A lot of 3's here. Negative 3 times negative 1 is 3. That adds up to 6. 6 times negative 1 is negative 6. Negative 13. So this one does have a remainder. Okay, so my answer, so this is going to equal 3x cubed minus 3x squared minus 3x plus 6 plus negative 13 over x plus 1. Some people are saying, can I put a negative for that last one? Yeah, because it's negative 13, but I'm just getting the habit of making a plus and putting whatever it is on top. Okay? So either way. All right, so that finishes up synthetic division. Now we're going to kind of combine that with a couple things here, and we're on to those guided notes. All right, so this is at your top. F of x equals 2x cubed plus 3x squared minus 11x minus 6. All right, split the work up. You should have two people or find somebody near you. One of you plug in -1, one of you plug in 2. All you're doing, you can use your calculator, you can do it by hand, I don't care. Plug in -1, plug in 2. Write those answers at the top. Carter, what do you got for? You got something for one of them? Both of them.
-1.
What'd you get for -1?
6.
All right, he got 6. All right, f of 2. All right, who's got F? Brooke, what do you got? 0. All right, so f of 2 is 0. All right, I believe those are right. You agree? Now, below that, let's just use what we learned. All right, I'm going to divide this by x plus 1. Okay, I'm going to use synthetic division. And you guys can split the work up here if you want. One do one, one do the other, but then you might want to write it down. So I'm going to plug in -1 here into the box into 2, 3, -11, -6. And I'm going to do this with +2. So it's 2, 3, -11, -6. All right, go ahead and do that if you would. All right, so now I add here, I get 2. 2 times -1 is -2. 3 times -2 is 1. I get -1. I get -12. I get +12. And then I get a remainder of 6. Over here, I get 2. 2 times 2 is 4. 3 plus 4 is 7. 7 times 2 is 14. 3 times 2 is 6. I get 0. All right, there is a connection. So here's where I wanted you to make the connection between what we just did. We said f of 1 was 6. And when I divided by x plus 1, what was my remainder? It was 6. We said f of 2 was 0. When I did this, I got a remainder of 0. Okay? Coincidence? I think not. It is not coincidence. So here's what. You get some bonus information. So if I'm dividing by x plus 1, if I'm using synthetic division, I'm dividing by x plus 1. Okay? Whatever my remainder is equivalent to f of -1. Okay? That gives me that fact. So if I get a 0, and you're going to learn that zeros are good things. Okay? That means it divides into it evenly. Then I know that. So here's the case. Synthetic division gives us this extra piece of information. Now, that leads us to the remainder theorem. Yes, it is a key theorem. If a polynomial f of x is divided by x minus a, okay, and it can only be x, minus a constant or x plus a constant, then the remainder, okay, is going to be f of a. Okay, whatever you get the remainder, whatever that number is, it's going to be equivalent. So now we got an extra piece of information. All right, now here's the thing. 9 times out of 10, if you're going to be asked to find f of negative 3, what are you going to do? You're going to plug negative 3 into the equation, right? I know that. I understand that. But there's going to be times when we're trying to find roots and zeros that we're going to use synthetic division. Well, the directions say use synthetic division. So if I want to know what f of negative 3 is, you put negative 3 into the box. You got 3, you got negative 4, you got 5, and you got negative 1, and you're going to use synthetic division. Go ahead and see what you get. I get 3, I get negative 9, I get negative 13. That should be positive 39. I believe that's 44. And I believe this is negative 132. And this is negative 133. So, all right, what do we got there? Holly, what is f of negative 3? Make sure we're in agreement.
3x squared minus.
No. F of negative 3 is just
Negative 133.
negative 133. Yep. F of negative 3 is just negative 133. Okay, that's all I asked to find. Now, what other fact do I know? It didn't ask me to find this, but I'm just going to put this down. Just pay attention. I know that 3x cubed minus 4x squared plus 5x minus 1 divided by what? You got to be careful here. What am I dividing it by, Matthew? X plus 3 divided by x plus 3 equals 3x squared minus 13x plus 44 plus negative 133 over x plus 3. So we get that extra fact. Depends on which way you're working. If you're dividing, you get the f of. If you're trying to figure out f of negative 3, then you get the answer to a division problem. Depends on what you're working through. But we get some bonus. All right, now down there at the bottom. I've kind of been talking through this several ways, but I want to just formally write it down or have it there for you. We talk about zeros, roots, x-intercepts. They're all the same. So if I say find the zeros, I'm looking for where it hits the x-axis. If I say find the roots or solutions, I want to know where it hits the x-axis. I want to know the x-intercepts. Little bit of foreshadowing here. Here's where we're headed. We won't get there until after the quiz, but without using your calculator, you can't type it in there. How can you find the zeros and graph this function? Okay, don't worry about writing this down, but this is where we're headed. Okay. Well, can you look at it and tell me the zeros?
Use synthetic division, you can guess and check.
You use synthetic division, we're going to guess and check. Okay, that's kind of where we're headed. But we want the synthetic division, so we got to know what we're looking for. We're looking for remainders of 0, which kind of leads to where we're at in the back. Okay, so kind of led right into the factor theorem. Okay. The factor theorem. We want to find the factors of that big, long expression. Okay, and what he says is right. We're going to use synthetic division. We're going to guess and check and try and figure that out. Do educated guesses and checks. All right, the expression x minus b is a linear factor of a function if and only if f of b equals 0. All right, let me tie that together, hopefully. You can write this down, pay attention, it's up to you. All right, there's your function. X squared plus 10x minus 24. All right, that factors. Mentally, what's that factor into? What are two numbers that multiply to negative 24, add to positive 10?
12 and negative 2.
12 and negative 2. So it factors into x plus 12 times x minus 2. I think we agree with that. All right, now how does that apply to the factor theorem? Andrew?
You put in synthetic division, negative 12 and 2 would both equal 0.
Okay, they both pull 0. That would be the fact. Now, I'm not even going to talk about synthetic division yet, because you can also say this. Since x plus 12 is a factor, That means you plug in negative 12, you get a remainder of 0, like you said. Since x minus 2 is a factor, that means f of 2 equals 0. So I can go back up here and I can plug in 2. 2 squared is 4. 10 times 2 is 20. 24 minus 24 is 0. Negative 12 will also work. All right, if and only if. Is that a typo? No, that's a math term. What's it mean? It means it works both directions. It means if f of negative 12 equals 0, that I can go the other direction and say that x plus 12 is a factor. And that if f of 2 equals 0, I can go this direction and say that x minus 2 is a factor. So if and only if is math terminology, and it means it works both directions. Not everything works both directions. Okay. So now let's put this together. How do you show that x, using what we just figured out, using the factor theorem? How do I show that x minus 2 is a factor of that? Okay, come on.
F of 2x equals 0.
Good. All right. So I'm going to kind of be very deliberate here. And I know probably on a homework assignment you're not going to be as deliberate. But so if x minus 2 is a factor of f of x, then f of 2 equals 0. And now what Andrew said, how do you show f of 2 equals 0? We're going to use synthetic division, because that gives us additional information. Okay, so it says show it. I want you to use synthetic division to show it. Don't plug it in, because we get extra information from the synthetic division. So we're going to take 2 in the box. I got 1, I got 1, I got negative 1, I got negative 1, and I got negative 18. All right, go ahead and do your synthetic division there. And it doesn't give a 0, then we have issues. 1 here, 1 times 2 is 2. 1 plus 2 is 3. 3 times 2 is 6. Negative 1 plus 6 is 5. 5 times 2 is 10. I get 9. I get 18. I get 0. Now this is where it's going to help us later on. So now f of x is equal to the product of x minus 2 times the depressed polynomial, which would be my answer. So that would be x cubed plus 3x squared plus 5x plus 9. Okay? Plus 9. All right, we good there? All right, so we're going to keep tying that together. All right, we got one last one there. Find the value of k for which the first polynomial is a factor of the second. A factor of the second means that when you divide, you're going to get a remainder of 0. We're going to use synthetic division. Basically, I'm saying x plus 3 is going to divide into there. Well, to show division, you're going to use synthetic division with not positive 3, but negative 3. What do I put here for my row? I know that's a 2. What do I put for the next one? Not x. X is always the variable. We've never actually put the variable, have we? We always put the coefficient. What's the coefficient? K. I don't know what it is, so put a K down. So if you're not sure, this is where we just kind of go into uncharted territories and we see what happens. All right, I'm going to go ahead, and there's a couple of different ways to do this one. Some people think about it differently, but I'm going to go ahead and just do the synthetic division. Let's just do it and see what happens. Well, what do? We take 2 plus 0, which is 2. What's our rule? Multiply 2 times what? Negative 3, which gives me. All right, now you run into something different. They don't. What are you supposed to do? You're supposed to add them, right? Well, I can't take in the atom. Well, you can. How can you represent it though? K minus 6. That's all I can do. That's all I can do. What's negative 3 times k minus 6? Negative 3k plus 18. All right, what do you get when you add those two? Negative 2k plus 18. Take that times negative 3. So just keep going through the math. Even though you're unsure where you're heading, just try it. Try it. Maybe some things will work themselves out. Negative 3 times negative 2 is 6k. All right, negative 3 times 18 is what? Negative 54. All right, what do I get when I combine those? 6k minus 30. All right, now how can I tie this all together? I haven't solved that. I haven't figured out what k is, but what fact do I know that if x plus 3 is a factor of that function, what should that remainder equal? Should equal 0. Okay? So right here, if this equals 0, I can figure out what my k is. So you take 6k minus 30 equals 0. Add 30. 6k equals 30. K equals 5. So there you go. Now you could go back and plug it in and show that it works. All right, that is 3-3. Homework, I pared this down. So you don't have a lot of, you don't have multiple examples of things, because usually you have homework last night, it just didn't work out, unfortunately. But you need to hit those. So basically every problem you see is important. You're not going to get a lot of repeated ones. 48, the reason you see that here is because in the book, there's a typo and it doesn't have the